So we're going to review we're going to review graphing polynomials. Polynomials you did see last semester. I think it was during cycle 4. So you did see this before. All of the stuff that we're about to go through are just very basic reviewing things that you should have already seen. So at the very top, the degree of a polynomial. So the degree of a polynomial is the highest power, or you could say exponent, the highest power or exponent of a variable in a polynomial. I'll put equation / function, because ultimately we will be graphing. So an equation or function. It's literally the highest power on a variable. You saw degree back in more than likely algebra 1, because you needed degree in order to figure out exponential functions, quadratic functions, all that good stuff. Even when you dealt with laws of exponents, you should have talked about what a degree is. So a degree is just literally the highest exponent of all the variables in your polynomial equation. So when we're graphing polynomial equations, it's technically not just one polynomial. There's infinitely many. You can have x to the first power, which we know x to the first power is just a linear function. X squared is a quadratic function. So standard form for quadratic is technically y equals ax squared plus bx plus c. That's technically what a quadratic function standard form looks like. Same thing if we had cubic. Okay, cubic would be x to the third power. So if we wanted to write that in standard form, we would put y equals, or f of x equals, ax to the third power plus bx squared plus cx plus d. That's how we would write it in cubic form. And we can do this for x to the fourth power, x to the fifth power, all of the different types of polynomials. But there's infinitely many. I can't go through all of them in one class or one school year. So the example that it asks you to do the following. So it wants you to write the polynomial in standard form, find the degree, and then write out the leading coefficient and determine if it's positive or negative. So in the space that you guys have next to you, let me zoom out a bit, I want you to take this and write it in its standard form. So standard form means that you're starting with the highest exponent and you're working your way down. So David, which one is the one with the highest exponent? What variable? Or what leading coefficient and variable? Just 9? There's just a 9 there? Give me that whole term. There you go. Negative x to the 9th power. Keep going. What's the next biggest exponent? So after x to the 9th power, negative x to the 9th, what comes next? Keep going. Keep going. Double check it. Make sure you look through all of them while David's writing. Did he put all of the items in? Yeah. You always start with the highest exponent and you literally just work your way down. Writing it in the standard form is extremely helpful because it'll help you with identifying what your leading coefficient is and what the degree is. So Jorge, in this pink equation that I just wrote, what's the degree for this polynomial, the entire thing? 9. Your degree is equal to 9. Is 9 even or odd? You're fine. That's what I thought you said. Odd. Yes. Okay, with that in mind, Jorge, last question. What's the leading coefficient? So leading coefficient is always in front of the variable with the highest exponent. -1. So I'm lazy, guys. I write LC for leading coefficient, but that's -1. And is that positive or negative? Don't overthink it, Jorge. Negative. Thank you. These two things help us determine our end behavior. So this whole first page is just talking about your end behavior. So for that little middle table that I have right here, I want you guys to fill in what's the degree and what's the leading coefficient for all of those. So right now I'm going to give you about a minute. Look at all of the examples, and I want you to give me the degree and the leading coefficient for each. Eurydia. For f of x equals 4, does it have a degree? Say it again. No, it does not. So I would put 0 here, because if you put x to the first power, or excuse me, if you put 1 as a degree of 1, you would assume that it's x to the first power, which you don't have for this. What's the leading coefficient, though? Well, I would definitely agree that it's usually none, because there's no other coefficient, or no other variable with the number in front. But since we have 4 here, it's technically acting as a leading coefficient because it's just a number. Even though it's a constant, it's technically defined as like a leading coefficient, if it's the only thing. For the next question, this 1 is not a leading coefficient. Obviously, you use the number that's in front of your variable. So can you give me the rest of the table? What's the next degree? And leading coefficient? Keep going through the rest of them. Is that a 9 or a negative? Yeah, 9. Okay, sounds good. So those are all of my degrees, all of my leading coefficients. Thank you, Eurydia. For all of these, it's not just important to know what the numbers are, but it's also important to know whether they're even or odd and whether they're positive or negative. So in this table at the bottom, very, very bottom of the page, in a second, we're about to do all of these, but this table you probably saw in some way, shape, or form in your Algebra 2 class. I know for my students, you definitely saw almost the exact same table, if not the exact same table. So for positive and negative leading coefficients with a even and odd degree, this is going to tell you the end behavior. So it determines if they're both going to be going up, both going to be going down, if one's up and down, or if the other's going to be up and down. So it just tells you what direction it's going to go. So for a positive leading coefficient and an even degree, think of x squared. How does x squared open up? Both ends go up. So literally over here, I'm just going to put up, because the left side is going to go up, the right side is going to go up. So in both directions, I'm going to have it going up. Again, when I think of even degree, my mind automatically goes to x squared. Hopefully y'all know 2 is an even number. So when it's x squared and it has this time a negative leading coefficient, where's it going to open? Down. They're both going to be opening down. So we're going to put down, down. Both ends of this graph on the left and right are going to be going down. For odd degrees, I automatically think of x cubed. So if you have, for instance, a positive x cubed, that should be going, is that down first, then up, or is it up first, then down? Y'all like dancing in your seats. It's so cute. You guys are going to be going down first, then up. So it should be going down first, then up. And if you had the negative leading coefficient with an odd degree, that should be going up first, then down. That one is still the ones that I even mess up on sometimes. So up first, then down. So for all of the 6 questions on the top, we're going to talk about which ones go where, and we're also going to talk about if it's going to be going to positive infinity, negative infinity, where that up and down actually means. So for example number 2 over here, I'm going to start with this one. You guys are going to do the rest. All of the steps that I'm doing, last class period said if they didn't graph these out, that's why they messed all of them up. So for this question, you're going to label 2 things for technically all of these: the leading coefficient and the degree. So leading coefficient and the degree. From this equation, I just want to know, is the leading coefficient positive or negative, and if the degree is even or odd. So, Enya, is the leading coefficient here positive or negative? Good job. And is the degree even or odd? Even. Okay, so I'm going to write that out. I'm going to put this is a negative, and it's even. If I was to graph this out, I know based on the table that you guys just helped me fill in, if it's negative, leading coefficient with an even degree, both ends should be going down. So I don't know exactly what the graph will look like, but it's going to have both ends going down. You guys tell me, because y'all saw this notation back in Algebra 2. As x approaches positive infinity, where's f of x approaching? Negative, because this part of the graph is going down. So it's going towards negative infinity. As f of x approaches negative, or excuse me, as x approaches negative infinity, so as it goes to the left, where's f of x going? Negative infinity. It's going to still going down. So right now I want you to do that for all of these questions. Label LC, label the degree, actually sketch the graph. If you don't believe me, ask your friends in my other class. They're going to tell you if you don't graph it, you're going to make a mistake. So take the time to graph these out, use the chart at the bottom, and then actually figure out how will this graph look. Will it go towards infinity or negative infinity? That's what each of those answers are for. So for all 6, I'm going to give you about, we'll say 3.5 minutes. Right, so for all of these, we should see hopefully something similar or some kind of pattern of some sort. Not really a pattern, but you should definitely be seeing these notes that we took down here show up on the top. So for example number 1, Itzel. As x approaches positive infinity, so I'm just going to graph this out because I like to have you guys see what you're seeing. You have a a positive leading coefficient in an even degree. So you should have had your graph going up in both directions like this. I don't know about the rest of it, but it should look something like that. As x approaches positive infinity, where's f of x approaching? Wow, Itzel, your voice has changed. Itzel, try it again. Thank you. And then what about as x approaches negative infinity? Also positive infinity. Good job. Do the same thing for 3. So for this one, hopefully you have a graph that looks something, it's positive with a odd number, so it should look something like this. What's your, as x approaches positive infinity, Itzel, where does f of x approach? Positive infinity. And as x approaches negative infinity, where's f of x going? Nods or shakes so far. Does this look okay? All right, next part. For number 4, this one is a negative leading coefficient with a odd degree. Gabriel, what did you get for as x approaches positive infinity for number 4? Negative infinity. Let's put the negative sign first. And then as x approaches negative infinity, where's f of x going? Good job. And do the same thing for 5. As x approaches positive infinity, where's f of x? And as x approaches negative infinity, where's f of x? There you go. And then for the last question here for number 6, you should have had for that 1/2 x to the 3rd power. Hopefully you know 1/2 is positive. I don't know why last class couldn't remember that. And then as x approaches infinity, f of x should also approach infinity. And as x approaches negative infinity, f of x should also approach negative infinity. Looking at all of these, are there any questions with what we just did? Without graphing it, we're trying to see where's the rest of the graph going without even graphing it. All right, if you're good, let's look at the next page. So on this next page, it says, using what you've just learned about multiplicities and end behavior, graph the following polynomial. Okay, let's be honest. I highly doubt from Algebra 2 you remember what multiplicities are. I'm going to refresh your memory on it. I'm going to talk about it, and then we're going to graph. For some of you guys, you might not remember it right off the bat with me going through this middle section. I'm going to try to make it as easy as possible. But if you don't remember multiplicity as it is now, wait until after I graph it. And when I graph it for the next question, if you still don't understand it, definitely tell me. Okay, so multiplicity. A multiplicity of a root r is the number of times that x minus r is a factor of the p of x function. So for multiplicity, it's going to be determined on how many times you have x minus r as a factor of your function. So depending on what your curve is, so we'll say this curve over here in red is f of x. And we need to figure out how many or what the multiplicity will be for this graph. That's what I'm trying to say, multiplicity. So whenever you have an odd multiplicity, it's literally going to cross through your graph. There's two multiplicities that we commonly see that are odd. When you have a multiplicity of 1 and a multiplicity of 3. The first one that I see here that says r, or the root a, has an odd multiplicity. The reason why is because it's crossing right through the x-axis, just like this line. What type of function do we know crosses just like a line? Linear. So this is just like a linear function. When you see something that's crossing like this, you can make a note that this is going to have a multiplicity of 1. So that's a positive 1 in case you can't see it. Multiplicity of 1. Whenever that multiplicity is there, it's reminding you, if you zoom in, if I literally was to zoom in as much as possible on this graph, even though it's a little blurry, it literally just looks like a straight line with a slope and a y-intercept is going right through it. The other odd multiplicity that you guys saw back in Algebra 2 was when you had a multiplicity of 3. Multiplicity of 3. For this one, oh my goodness, my handwriting looks horrible. Let's try that again. Oh, that's close enough. All right, so for multiplicity of 3, I'm going to graph this one out really quick. It's just going to be a sketch of what this graph can look like. So you're going to have some kind of curve. Let's say it goes down here. And over on this side, it looks like this. Go ahead and take a second to draw it. It's not going to be perfect, but I want you to make sure, especially here, that you have this little curve shape. What kind of function has this shape? What type? Cubic. This is a cubic function. So anytime my students see a multiplicity of 3, it kind of wiggles through the x-axis. That's how it's a clear indication that it's going to be a multiplicity of 3, because it's going to have that curve to it. It's literally going to wiggle through the x-axis. And then the last type that you should definitely be familiar with is if you have an even multiplicity. Even multiplicities are like x squared, x to the 4th power, x to the 6th power. We really don't see 4th and 6th, but we do see x squared. Anytime we have a multiplicity of 2, it's literally going to bounce off of the x-axis at one way or another, either bouncing up or it will literally bounce down. So over here to the side for your multiplicity, I'm going to highlight this. For an even multiplicity, it's going to touch the x-axis and literally just make a U-turn. It's going to bounce right off of it. So for the question on top, we're going to do it, and I'm going to make one little note before we actually start solving. So at the very, very top of the page, along this little border at the top, I'm going to write this out really quickly. When you have an even degree, even degrees are going to have an even number of zeros. Even degrees have an even number of zeros. And I'll add in one other thing, or they'll have no zero. Point is, it's going to be even. So an even degree is going to have an even number of zeros, or no zeros at all. What's a zero, by the way? X-intercept. So please don't look at me crazy when I say 0. An odd degree is going to have an odd number of zeros. So an odd number of zeros. I'm supposed to say zeros, guys, but my hand is not cooperating today. So for even degrees, you're going to have an even number of zeros. For odd degrees, you're going to have an odd number of zeros. So for this question, let's go ahead and graph it. With graphing it, if you think back to last year, it's a lot easier if you started off when it's factored. So I'm going to give you some steps, because I love giving you guys steps, so that way when you come back after a break or after an absence, you have something to reflect back on. So over here to the side, I'm going to put my steps. Step 1 is to factor. And lucky for you guys, I have the standard form equation here, and I have the factored form down here. The second step, after we factor, is to find any zeros So find your zeros and your multiplicity. Find your zeros and your multiplicity. Remember, your multiplicity is important because it tells you what's happening to the graph. Is it crossing through the graph or is it bouncing? Step 3 is to find your end behavior. And we saw that on the first page. When you're looking for your end behavior, you're trying to see what's the leading coefficient and what's the degree. And then for the last step, you're going to find the y-intercept. So find your y-intercept. So these steps seem like a lot, but it's really not, especially since I've already written this out for you in factored form. If not, you would have to factor it on your own. So for the question on top, the one that's in standard form, we don't have to do it right now, but I'm going to go ahead and kind of knock it out of the way. For this question on top, go ahead and write this in descending order because that's going to drive me crazy. That very top equation at the top, write it in descending order, which is standard form. So David helped us with this earlier. The highest exponent is x to the 4th power plus 2x cubed all the way down to 12. Okay, so I like to number things so that way you guys can follow my process. So for step number 1, it says to factor. Okay, well, luckily for us, step 1 is done. So this is in blue. It's factored. Step 2 is to find your zeros and your multiplicity. In order to find my zeros or multiplicity, Hussein, what do I need to do? To find my zeros, let's start simple. How do I find zeros from my factored form? Equal all of the what? Yeah, all of the binomials in that parentheses, yeah. All your binomials. So technically what he's doing is that he's setting equal 0 to x plus 1, x minus 3, x plus 2 squared. All of those are going to be set equal to 0. So don't just start setting all of them equal to 0 at one time. Make the entire equation equal to 0 first, and then split it up into 3. So set x plus 1 equal to 0, x minus 3 equal to 0, and x plus 2, not 4, equals 0. The thing that's written at the top of this page is driving me crazy right now. Do you guys agree? For this problem, do I have an even degree? Yes or no? Yes, I have an even degree. Is there an even number of zeros here? If I was to solve each of them, is there an even number? I'm hearing yes and I'm hearing no. Who said yes? Go ahead, Fatima. Why are you saying yes? Say it one more time, but a little louder. There's 2 of them. Exactly it. So even though there's only 3 things that we're solving, we technically have 4 zeros. And the reason why is because of this squared. That squared means you're going to have 2 of the exact same answer at whatever x plus 2 equals 0 is. So what some teachers will call it a double root. That's what that means. So it's still going to be 4 answers, but one of them is the exact same. Good job. So we're going to subtract 1 on each side to find our first x-intercept. I'm going to add 3 to each side to find the other. And subtract 2 for our double root. Even though I'm only going to graph it one time, it's considered 2 answers for some reason. Now I need to look to see what the multiplicity is. So if you think back again to Algebra 2, Giselle, what's the multiplicity for x equals 1? Negative 1 here. What's the multiplicity going to be? I'll give you a hint. Look at this binomial. What's it raised to? What power? 1. Right outside of this binomial is an exponent of 1. That means that your multiplicity is 1. Giselle, go ahead and do that for x equals 3 and for x equals negative 2. What's the multiplicity for x equals 3? 1. And for negative 2? 2. That one was one Fatima told us has a double root. So you want to make sure you put that 2 there. Each of these that I'm highlighting in yellow, I'm going to need in a bit. So this is my multiplicity and my zeros. Luckily, I rewrote the end behavior earlier, so I can actually look at that equation to see what step 3 is going to be. So to find my end behavior, I need the leading coefficient and the degree. So step 3 over here is to find the leading coefficient and the degree. Alexis, what's the leading coefficient here? 1. And is it positive or negative? Positive 1. And what's the degree for this? 4. And is 4 even or odd? So if you need to, look back at the other page. If you have a leading coefficient that's positive and an even degree, what is the end of your graph going to look like, Alexis? What's the end behavior going to look like? If you need to flip, feel free. Both sides go up. Good job. I'm highlighting this because I want to make sure I pay attention to it when I graph this out. The last step, over on the left-hand side, I'm not going to move it because I know you guys are writing, but it says to find the y-intercept. How do I find the y-intercept? What do I have to do? Plug in 0 for x. So I'm going to plug in 0 for x and get my y. I will mention, since I have two equations here in red and that I underlined in blue, we can technically use either one of these. But I'm lazy. I don't like having to do too much extra work. If you use the factored form, you're going to have to multiply. If you use the standard form, which is right here, you won't have to multiply. What's 0 times anything? 0. So there's probably going to be a lot of zeros in this. So we're going to have y equals, I'm going to use the standard form, 0 to the 4th power plus 2 times 0 cubed minus 7 times 0 squared minus 20 times 0 minus 12. If I was to multiply this out, 0 to the 4th is 0, 0 cubed is 0. What's the answer for this going to be? Negative 12. Literally, everything else cancels because it's being multiplied by 0 at some point. So the last thing I need to graph is this negative 12. That's my y-intercept. So I know if you're like me, you have no more space on the front side. Flip your paper to the back, and I'm going to zoom out on my page. Everything that I've highlighted in yellow, I want you to create your graph right now. So on the back side of your paper, all of the items that are highlighted in yellow at the top, I want you to graph your equation right now. Graph it out. You have your x-intercepts, your multiplicity, your y-intercept, and your end behavior. If you don't remember what to do, sketch out a graph, give me the x-intercepts and the y-intercept. That's the least you can give me. This graph does not have to be perfect. Give me a sketch. I'm going to leave it up for about a minute, and then I'm going to flip it over to the back side and graph it myself. Give me something, though. If you're still graphing, you're fine, but I'm about to flip it over so that way I can graph it myself too. So we have our coordinate plane. I have 3 x-intercepts. We have it at -2, -1, and we'll say +3 is over here. I have a y-intercept at -12, and that's all the information I have. Okay, so on the front side of this page, I have a multiplicity of 1 for x equals -1 and x equals 3, and I have a multiplicity of 2. I also know, which I can actually start this graph with, is up, up for my end behavior. So from the left-hand side, I'm going to start this going up with my pen, and it's going to go down to x equals -2. I said at x equals -2, we have a multiplicity of 2. What does multiplicities of 2 mean? What are you going to do? It's going to bounce off. It's going to make that U-turn. So I'm literally going to go all the way down to x equals -2 and bounce it off. Your graph might look a little different from mine, but I always check on your tests and quizzes the x and y intercepts and the end behavior. That's all. If your graph goes a little lower than mine is, I really don't care. Okay, the next x-intercept I'm going to get to is -1. So -1 has a multiplicity of 1. How does it cross? Like what type of function? Linear. So I'm going to cross it like a linear function. So I'm going to go up a little bit more and cross it going down, just like that. As it goes to the right, I can't just skip ahead to 3 and then come back down to -12. You have to go from left to right. So -12 is my y-intercept. So I'm just going to keep going down somehow. Hit my y-intercept. If you want to have it like bounce through the y-intercept, you could do that, or you can have it go down a little further. I'm going to have it bounce off. You don't have to have it bounce off. It's not changing the answer. If you want to have it cross through, it's fine. But the main thing I check is to make sure you hit the x-intercepts, y-intercepts, and have the end behavior. The last thing is the negative, or not negative, the positive 3, which is a multiplicity of 1, which you guys told me is linear. So I can have it curved this way, and then I just literally want to have it go through as a straight line. I'm going to start putting it as a cubic function. So just have it go through as a straight line. Your graph might not look like mine, and it's okay. I'm only checking these things. That's all I want to see. And, of course, that the ends are going up. Are there any questions on what we just did?